anytime you encounter interest in real life, it's almost definitely going to be some form of compound interest. What that means is that after some time period, the interest is going to start gaining interest as well as the principal gaining the interest. So let's take an example of this and think about putting $1,000 into an account that's going to earn 2% interest every year, right? So if we were thinking about our simple interest formula, remember if we wanted to know the future value, we were going to take our principal and we were going to add to that the interest that we earned. And our interest formula was our principal times our rate times our term. And remember we went through and we actually factored out that principal, so we had 1 plus our rate times our term. So if I wanted to know the future value of this account after 1 year, I would do $1,000 times 1 plus 0.02 times 1. So the future value of this account would be $1,020. Now, if I left the money in for another year and the interest started earning interest after another year, so this would be my future value after 1 year. So I'm going to put a subscript 1 here for me. My future value after 2 years would be my future value after 1 year, so this new principal rate that I have, times 1 plus 0.02 times 1. So I would end up with a future value of $1,020 times 1.02. So my future value after 2 years would be $1,040.40. Now notice we know that $20 of that was the interest on the $1,000, but the 40 cents is the interest on my $20 interest that I earned the time before. And interestingly, if I look at what my F1 value was, my future value after 1 year was, it was my principal, my $1,000 times 1.02, right? My future value 2 ended up being my future value 1 times 1.02, 0.02. And if I plugged in my future value 1 into this here, I would actually have the principal times 1.02 times 1.02. So this is actually the principal times 1.02 times itself is actually 1.02 squared. So whenever we have annual interest that we're compounding annually, we can actually take our principal times 1 point whatever our rate is, the decimal form of our rate. So 1 plus the decimal form of our rate. And we can raise it to the number of years that we're going to leave the money in. So this is actually related to our compound interest formula. So the compound interest formula tells us that the future value of our money is going to equal our initial principal times 1 plus the decimal form of our rate raised to the time, the term, the number of years that we're going to be putting the money away for. So this is our annual compound interest formula. Certificate of deposits, or CDs. Whenever you see at a bank they're talking about a CD, they're not talking about a music CD. They're talking about a certificate of deposit. So a certificate of deposit is an option for saving money that banks offer, and they tend to have slightly higher interest rates than a savings account. And they tend to require you to keep your money in them for a longer period of time. So basically what happens with a certificate of deposit is, in exchange for you lending your money to the bank for a longer period of time so they can lend it more freely and don't have to have it for you immediately, they will reward you by giving you a higher interest rate. So certificates of deposit generally take a little bit more money to start than a savings account, but if you have a chunk of money that you don't need immediately, people often use a certificate of deposit as a relatively safe investment for their money. So let's say we have a $5,000 certificate of deposit. It's earning 5% annually, and we're going to have to leave the money in there for 10 years. And we're going to find out how much the certificate of deposit is going to be worth after 10 years with the interest compounding annually. So we can take and find our future value by taking the principal times 1 plus our rate to the time. We can use that annual compound interest formula that we have. And so our future value is going to be $5,000 times 1 plus 0.05 to the 10th power. So our future value will be $5,000 times 1.05 to the 10th power. And once you get it simplified down like that, then it's fair game to punch that into your calculator to find out what it is. So we can have 1.05 raised to the 10th power times $5,000. And I said it in that order because one of the most common things that people will do wrong with this is they'll multiply 5,000 times 1.05 before they raise it to the power. But remember, order of operations demands that we take care of our exponents first. So this is our first step, and then we do our multiplication as our second step. So once we work this out and we get our order of operations right, we have that our CD will be worth $8,144.47 after 10 years. Now let's take a look at the same example, except for this time the interest is going to compound quarterly. So everything's the same except for this compounding quarterly statement. So quarterly, there's 4 in a year, all right? So 4 quarters in the year. This is really important. So remember we had our equation that we had the future value of our money was going to equal our principal times 1 plus our rate to the power of the number of years. And that was our annual compounding formula. So now, if I think about this, I know that I'm going to add in my interest 4 times a year instead of just once. So remember when we figured out why this formula should have this exponent like this, it was like every year was adding to the exponent. So what we're actually going to end up with for our quarterly is, instead of years, like this did represent, now this is going to represent the number of times compounded. And so that we don't get this confused, we'll use a capital T instead of a lowercase t. So we'll take our equation and we'll have our capital T. And the way you figure out what capital T is going to be is we take our number of years, our lowercase t, so number of years, and we multiply it by n. So n is going to be number of times compounded per year. So if we take the number of times compounded per year, we multiply it by the number of years, we're going to get the total number of times compounded. Now the other thing that has to change for this is we have to change our interest rate. So the reason for this is our interest rate was given to us as an annual percentage rate, right? So annual, if we're compounding every quarter, we don't get the full annual rate. Instead, we get a quarter of that since we're compounding quarterly. So we have a value here, and we call it lowercase p. And this lowercase r was our annual percentage rate. Lowercase p is going to be our periodic interest rate. Right, so for our periodic interest rate, what we do to find this, lowercase p is going to equal our annual rate divided by the number of times we're going to compound each year. So what this does is it breaks it for quarterly, it breaks our annual interest rate up into fourths, so it gives us a quarterly interest rate. And if we were to compound monthly, so every month, we would use 12 for our n, and this periodic interest rate would be a monthly interest rate. So let's go forward with our compounding quarterly example that we have here, and let's fill in some values. So I have my future value is what I'm solving for still. My principal doesn't change, so I have $5,000 that I'm going to invest. And I have 1 plus my periodic interest rate is going to be my annual interest rate as a decimal, so 0.05, divided by the number of times I'm going to compound each year. So 4 is my quarterly number. And I'm going to raise this to my number of years times the number of times I'm compounding each year. So 4. There's a 4. All right, so I simplify this and I get $5,000, 1 plus 5% divided by 4 is 0.0125, and 10 times 4 is 40. So I now have my future value is going to be $5,000 times 1.0125 to the 40th power. So we'll see what this CD would do if it was quarterly compounding. Remember, we're going to do the exponent part first. So 1.0125 raised to the 40th power. And then we can multiply by our $5,000. So we'll get a future value of $8,218.10. So there's our future value compounding quarterly. So let's take a look and see how it compares to our annual compounding. So with annual compounding, I had $8,141 or $8,144, and 47 cents. And with quarterly compounding, I have $8,218.10. So if I want to know how these compare, I can subtract them. And I can find out, if I do that, $8,218.10 minus $8,144.47. So I make $73.63 more over the course of 10 years if it's compounding quarterly instead of annually. This will be true no matter what, however you're compounding. So honestly, the more compounds you have, so the more regularly something compounds, the better off you are if you're making the money. And if you're paying the money, the less frequently the money compound or the interest compounds, the better off you are because you'll owe less money. All right, one of the places that people tend to acquire debt fairly early in their life is through student loans. So say we have a student loan that we took for $10,000 in our freshman year. We have an annual percentage rate on it of 6%. And we're not going to make any payments on it for 4 years. So we're just going to let it sit there for 4 years because we're a student for 4 years. And it's compounding monthly, though, while it's sitting there. All right, let's see how much money we'll owe by the time we graduate. So remember, our future value equals our principal times 1 plus our periodic interest rate to the number of times we're going to compound it. So the future value of this loan is going to be $10,000 times 1 plus the periodic interest rate of 0.06 divided by 12 raised to the 4 years that we're going to let it sit there and compounding the 12 months every year. So the future value of this loan, let's simplify some stuff down, is going to be our $10,000 times 0.06 divided by 12 is 0.005. So we have 1.005 to the 48th power. And again, we're going to follow our order of operations. So we're going to do 1.005 raised to the 48th power. And then, after we've raised it to the power, we get to multiply times 10,000. When we do that, our future value is going to be $12,704.89. So by taking a $10,000 loan in our freshman year and letting it sit there with the interest on it compounding monthly for 4 years, at the end of 4 years, we're actually going to owe $12,704.89. There are lots of student loans that do exactly this. There are other student loans where they don't compound the interest. The loan gains interest the whole time. So it's gaining that simple interest of 6% every year for the whole time that you're in school. So the 4 years. So you'll end up owing interest on that loan at the end, but it's not compounding, so it's not adding into the loan yet. So that saves you some money there. And if you can pay off the interest before it compounds, then the loan that you're starting to pay on is really only a $10,000 loan. There are other student loans that don't have interest on them until you graduate, and that is the kind of loan you want to go for. But I can't stress enough, if you have a loan that's gaining interest, even if you can't afford to be making payments towards the principal, if you can pay off some of the interest along the way, you can save yourself a lot of money in the long run. So let's take a look and see, how much would you actually have to pay every month for the interest on this loan? So the interest on this loan, take our interest equals our principal times our rate times our term, right? So we can amend this. So our principal is $10,000. Be nice if it was $0, right? $10,000. And our rate, we can do this so we use our monthly rate that we had figured out already of 0.005. So we can multiply times 0.005. And our term, if we just want to know how much we'll have to pay in 1 month, then let's just have it as 1 month. So if I multiply this out, I end up figuring out that for $50 a month, I cannot owe an additional $2,704 at the end of my 4 years. When we're talking about interest compounding, one of the things that we need to talk about is this idea of continuous compounding. Continuous compounding does not come up very much in life at all, but if you ever see the opportunity to invest in something that is continuously compounding, then it's almost always a fabulous option. Whenever you are borrowing money, you want to avoid continuous compounding at just about any cost. So continuously compounding actually uses that constant E. So our formula is our future value equals our principal times that natural number E, that constant, raised to the rate times the time. And the rate is our annual percentage rate in decimal form, and the time is the number of years. So let's think about my CD that I had before. So our CD, remember we had $5,000 in our CD, and we were earning 5% APR. And it had to be in for 10-year term. All right, so this time we're going to be continuously compounding and see what happens. So our future value is going to equal our principal, so $5,000, times E, the constant E, raised to the 0.05 times 10. So I can simplify my exponent there. So I have my future value is $5,000 e raised to the 0.05 times 10 is going to be the 0.5 power. And again, we can plug this into a calculator, but we have to be super careful about doing the e to the power first. So we'll do e to the 0.5, and once we have that, we can multiply it times $5,000. And we end up with a future value of $8,243.61. And with the continuous compounding, this amount is roughly $25 more over 10 years than our compounding quarterly option. So we have this this idea of the interest constantly being added in as soon as we earn it does get us more money. And you can imagine scaling that from our $5,000 in 10 years with this interest rate. It can get pretty extreme pretty quickly. All right, so with compounding interest, one of the things that you'll notice is that the annual percentage rate is not actually the amount of interest that you're going to earn over the course of the year, because it gets compounded throughout the year, and then we earn interest on interest, changing the interest rate, that combination of percentages that we talked about before. So the annual percentage yield, what it is it's a chance for us to know, well, what does that annual percentage rate really mean with the compounding? So what this is doing is it's telling us really like what the effective rate, interest rate is. So this is the annual percentage increase on the value of our investment or our loan over the years. So we can find this several ways. So the way that we find this is we take basically what's in the parentheses for our future value with our compounding formula. So 1 plus our rate divided by that n value raised to the n minus 1. Now I used n for this before, and I always use n. N is the number of times compounded per year that our interest is going to be compounded every year. All right. Your book uses a capital T here, which I think is misleading because it uses a capital T in other places as well. So we'll stick to n, all right, for the number of times compounded per year. So in the case of my CD, if I want to know how much money when it's compounding quarterly am I actually making every year, what is my interest rate? So I can compare maybe my continuous compounding CD versus my quarterly compounding CD. I would, for my quarterly, the APY is going to be 1 plus, my rate was 0.05 divided by 4 raised to the 4th power minus 1. Now notice the 1 in here is the principal, is for the initial principal that's earning interest, because it's earning interest along the way. And then we subtract out our starting principal with the subtracting 1. But that initial principal being added in there, we need to do that because it's going to impact what our APY is when we're compounding multiple times a year. So if we work this out, remember we'll have APY equals, we need to simplify what's in our parentheses, so I have 1 plus 0.05 divided by 4 was 0.0125 raised to the 4th power minus 1, and again continue to simplify, so I'll have 1.0125 raised to the 4th power minus 1. So I have 1.0125. The order of operations is easy to follow here because my exponent is the first thing to the left. So do that, then subtract 1, and I get an APY of 0.0509. So what this is saying is my annual percentage yield in percent form is 5.09%, which is more than the 5% that's my APR. Now, what was in my parentheses was different when I had continuous compounding. Remember, we're really just dealing with the thing that's being raised to the power, and in this case it's really just the e to the r. So let's look at our continuous compounding. So continuous APY, PY. So in this one I'm going to do the e to the r part and subtract 1. So I'll have my APY equals e to the 0.05 minus 1. And I can plug that into my calculator. E to the 0.05 minus 1. And I get my APY equals 0.0513, or my APY is 5.13%. So we can see that difference with the continuous compounding in the APY.